In April of this year, our CTO, Nick O'Leary, gave an awesome masterclass at Hannover Messe. So today we'd like to share that awesome talk. Hey there, my name is Christopher Sandoval. I'm the Developer Relations Advocate here at FlowFuse. So Nick, take it away.
Good afternoon, everyone. The title of this talk is a question that most manufacturers are wrestling with right now. How do you actually bridge IT and OT without needing a 3-year program, a 9-figure budget, and a complete rip and replace of everything on your factory floor? The answer, increasingly today, is turning to AI. But not AI as a buzzword, but AI as it applies to your infrastructure. AI embedded into the platforms your teams are using every day to move data, build integrations, and run their operations. And that's why I wanted to use this session to dig in a bit about how we're seeing this take place in the context of what we do at FlowFuse. Before we get to that, a little bit about myself and why this is interesting to me. So I'm Nick O'Leary. I'm the CTO and co-founder at FlowFuse, and I'm the co-creator of Node-RED, the open source flow-based programming tool that's at the heart of what we build here at FlowFuse, and is becoming just a widely adopted tool right across not just manufacturing, but a whole host of other industries and applications. So let's start with the problem that we want to talk about. Digital transformation has been a priority for manufacturing for years, and yet most organizations are still fighting the same battles they were fighting a decade ago. And why is that? The underlying challenge hasn't changed. You've got fragmentation, data trapped in silos, IT and OT teams operating in parallel but not really together. You have vendor stacks that don't talk to each other, and an integration problem that grows faster than anyone's ability to solve it. Now, our thought here is that AI can change the economics of that challenge, and it can change it permanently. But to understand how, we need to be honest about what the status quo actually is. Here's the central paradox of most industrial operations. Industry generates more data than ever before. You've got sensors, PLCs, historians, SCADA systems. The volume of data is enormous. And yet, that data rarely becomes information. It rarely drives business value driving decisions. And why is that? It's because the chain between data and insight breaks down at almost every step. The data's siloed. It sits in one system and it can't talk or connect with another. When you try to integrate it, the complexity explodes. Standards conflict, custom integrations become fragile. And the more you try to surface data for operational use, the more infrastructure you end up having to maintain. And the volume doesn't solve anything, it just makes the problem worse. So here's where most manufacturers find themselves. Data is trapped, the systems are fragmented, and innovation is slow. Not because the people aren't capable, but because the architecture makes every new initiative a major project. Industrial transformation shouldn't be this hard. The data exists, the use cases are clear, the return on investment is proven, but the barrier is structural, and it's one that a better architecture, when applied appropriately with AI, can help remove. And let's talk a bit more about the costs of this fragmentation. Unplanned downtime. When systems are siloed, root cause analysis is slow. By the time you've traced a failure across disconnected systems, the damage is done, and the cost, depending on your industry, can be huge. You have IT bottlenecks. Operations teams with genuinely good ideas wait months for IT resources that are already widely stretched. Competitive advantage evaporates while the tickets pile up in that work queue. You have vendor lock-in, proprietary systems that trap organizations in expensive upgrade cycles. You can't innovate, you're just maintaining what you've got. And your data, it's trapped. The most valuable operational data in your business is locked in systems that can't share it. without integration, insight at scale is impossible. And these aren't edge cases, these are the daily reality for a lot of manufacturers. Integration complexity is the hidden tax on every initiative. The thing that ties all of this together is that integration complexity. Every point-to-point connection you build is a liability. Every custom integration is something that has to be maintained, updated, and eventually replaced. And integration complexity is the hidden tax. It's what turns a 6 week project into a 6-month one. It's what makes just add AI sound laughable to anyone who's actually tried it. Now, the traditional response to this problem have 3 common failure modes. Point solutions don't scale. They solve one problem in one place and create new integration challenges everywhere else. Custom integrations break over time. The engineer who built it moves on. The system it connected to gets upgraded, and suddenly you have a production critical integration that nobody wants to touch. And the costs outweigh the benefits. By the time you've scoped, built, tested and maintained a custom integration, the return on investment has often evaporated. A slide with random big numbers on to make this all sound impressive and important, but a large proportion of manufacturers cite the IT-OT integration as one of their biggest barriers to effective digital transformation. The timescales for achieving any sort of data integration can extend well beyond what the engineer thinks should be a really quick task. And this all just adds up to an operational cost across the organization. Now, the idea here is if you can get the digital integration correct, with an architecture that supports and a system that doesn't just improve on these numbers, it can change the underlying economics that produce them. And that's the fundamental problem with the way industrial software has traditionally been built. That the complexity grows faster than the value it brings. The more you add, the harder it becomes to maintain, the harder it becomes to innovate. You reach a point where just keeping the lights on consumes all of your capacity. And that's the trap. And it's exactly the trap that we believe a composable architecture with an appropriate level of AI assistance can be designed to break. So what does AI actually bring to this problem? It can bring understanding to the data. Not just moving it, but interpreting it, contextualizing it, making it useful without a data science team. It reduces your manual integration effort dramatically. Tasks that used to take weeks of specialist time can now be completed in hours by engineers who know the process, not just the code. And it proves expert insight at the point of need. In the flow, in the tool, in the hands of the person closest to the problem. Ultimately, the key shift is that AI can turn the data into action. And it does it faster than any previous approach. And this isn't AI as a separate product you deploy and bolt onto the side of what you have. It's looking at ways at which the AI can be woven into the fabric of how your teams build, monitor, and operate industrial applications. We have to be honest about this because it's easy to just use the AI buzzwords and all that language and make it sound like a new nirvana. And often a lot of this just doesn't survive contact with the way reality exists in these systems. AI is not a magic solution. It has its own implementation cost, its own idiosyncrasies, its own failure modes. It generates new requirements. MCP, which we'll come to, isn't a drop-in. AI agents don't come out of the box ready just to work in your environment. You need training, new deployment patterns, and new operational thinking. AI creates pressure between teams. The leader who wants to just use AI is talking past the OT team who wants to reduce complexity, who is in turn talking past the IT team who needs to ensure a secure development environment. And it isn't an immediate band-aid. You can't deploy AI without a framework or a platform or an architecture to support it. Done wrong, it demands significantly more legwork and investment than the problem it was meant to be solving. Now, the reason I'm telling you this is because the answer isn't AI in isolation. The answer is AI embedded into your platform that can handle the hard parts, the governance, deployment, the integration, allowing your teams to focus on the outcomes. Which brings us to the architecture of such a solution. The industrial software architecture that exists today were designed for a different era, one without AI, without cloud, and often without the assumption that OT and IT would ever meaningfully converge. And we want to rethink that, not from scratch, but with a clear set of principles. So the architecture we think about at FlowFuse is built on these 4 principles. Composability. Solutions built from a modular API-first components that you can combine, reconfigure and extend without having to rebuild from scratch each time. Open and interoperable. Build on open standards at both the data and application layers. No proprietary lock-in, no dependency on a single vendor's roadmap. Real-time data flows. Making data available where it's needed, when it's needed. Not thinking you have to just get all your data into one big data lake, but thinking where is the value in the data? Is it at the edge? Is it in the cloud? Or anywhere in between the two? And having AI able to assist and embed throughout that experience, not bolted on, not a separate tool, but woven into that developer experience, the debugging experience, and the operational experience of the platform. The open source foundation matters more than people often appreciate. It means you avoid a lock-in to your technology stack. It can mean a faster innovation cycle because you're building on an ecosystem with thousands of engineers actively contributing and developing. It means you inherit a community, a library of integrations, and a track record that other tools simply can't match. This is why we have Node-RED at the heart of what we do. There are hundreds of thousands of Node-REDs pinging back via our telemetry every day. We know that's a small fraction of the true scale of deployment of Node-RED. It comes with first-class support for many industrial protocols, many non-industrial protocols. There's almost no limit to what the sort of data integration solution you can build with Node-RED. And with a community that is building new integrations, over 5,000 nodes from the community, there's almost always already a solution to the sorts of problems, integration challenges you are facing within the Node-RED ecosystem. And we like to think about how Node-RED can apply right across the industrial stack. So ISO 95, familiar sense of the different levels of the industrial stack. And we think about how Node-RED can apply down at levels 0 and 1, the field layer. Data extraction, protocol conversion, hardware control directly at the sensor and PLC level. At level 2, the control layer. You've got edge computation, real-time analytics, data collection before anything has to leave your plant floor. The manufacturing operations layer at layer 3. Node-RED drives HMIs, dashboarding, alarming, recipe management. It integrates with SCADA systems and handles centralized computation. And at level 4, the enterprise layer. It connects to your ERP systems, drives global dashboards, handles messaging and reporting across the entire organization. And this isn't theoretical. This is the deployment pattern we see with our customers in production right around the world. Having a common tool that can operate right across that stack, giving the engineers, the operators, a common language almost to build their data fabric, spanning the whole stack. I mean, this is a very full picture. I won't go into it in great detail, but yeah, a very typical architecture where you have an individual body shop with various lines and systems running on it. You have a plant-wide view, the company IT service and cloud systems. And it's not uncommon to find Node-RED dotted throughout. Now, in a lot of, it tends to start at this end, because it tends to be the OT engineers who are, again, the people closest to the problems they're trying to solve, are just picking up the tools to solve those problems and are just being opportunistic in running Node-RED alongside their machines because they know it can access their data. But as that matures and you realize you can bring Node-RED right further up the stack, again, you've got a common platform that can be applied for the different personas, the OT engineers, the IT, the plant managers, the execs at head office, wherever, can have a common view of the world. And this is where FlowFuse comes into the mix, because once you have all of this Node-RED, the open source project, running right across the organization, you need to have a way to manage that in a way that keeps IT happy, meets all of your security and regulatory requirements in that space. So this is what we set out to build with FlowFuse, and it's all about providing that single point to deal with the connectivity, orchestration, dashboarding, unified namespace, whatever it may be. They all depend on Node-RED in this architecture. And whilst that's incredibly powerful, it's not a platform in itself. It doesn't come with the tooling to manage deployment, security, or the other sorts of controls you need to scale. So this is why I started FlowFuse, to address that problem. We take the flexibility of Node-RED and wrap it up in everything that enterprise need most to deploy and manage industrial applications securely, reliably, and at scale. So we have centralized management of those Node-RED instances, whether they're running inside the platform or at remote edge locations across your infrastructure. Role-based access control, audit logging, single sign-on, CI/CD pipelines, version control, a long list of features. It really superpowers Node-RED for the enterprise. And it gives us that platform with Node-RED right across the enterprise to then bring a integrated AI experience right across the board. So let's talk about what AI can do to that development experience. A quick show of hands to help me out. Who is familiar with Node-RED already, for those listening in? A few hands up, a general mix. With Node-RED being a low-code development tool where you can visually drag and drop and draw your flows, very accessible to your OT engineers because they can understand how to solve a problem as a flow of data, and the Node-RED editor helps you build that flow by expressing it as a flow of data. But when we look at how AI can even further accelerate that development, the goal here is really much turning a development cycle of months into a development cycle of weeks, if not days, if not hours. Generating your flows to do your data integration, your dashboarding to show your, to present your HMIs, to create your data transformations in real time. And we're not replacing the engineers here, but we're removing bottlenecks that can slow them down to be able to do this effectively. And ultimately, that's how you bring value to the organization, is the speed to deploying these solutions. So we say months to weeks. I mean, again, they're imaginary numbers just to illustrate a point, but one path you may take traditionally is you write the integration spec. That takes a couple of weeks to get reviewed by the right experts, to look up the right data sheets for the machine, to understand what you actually need to do. You engage a system integrator or a developer. That takes time. Build and test takes time. Deploy and validate takes time. With an AI assistant, where you can describe your goals in plain language, the AI can generate the flow to get you started in seconds. Your OT engineer can review that, tweak it, fine-tune it, but it's given them that head start that they wouldn't have otherwise had. And then with the platform enabling you to deploy that across all your sites almost instantly, you are turning those months into weeks, if not days, if not hours. And that's not a marginal improvement. That's a structural shift in what's possible and who's capable of doing it. The deeper implication of that shift is about who can build those solutions. When AI removes the specialist bottleneck, operation teams stop having to wait for IT, they can solve the problems faster, and they reinvest that time in innovation rather than maintenance. But the key here is we're not replacing any of their responsibilities. We've removed the bottlenecks. We're empowering all the already overloaded teams to do what they're being asked more effectively. And ultimately, it's the people closest to the problem become the people building the solution. And that's a fundamental change in how industrial organizations can operate. Those closest to the problem are empowered to build the solution. And that's kind of at the core of what we're trying to achieve. We're not replacing the engineers, we are empowering them. And ultimately, allowing them to be more effective, more efficient. And that is how you achieve the digital transformation, by realizing that value whilst it is still value to be had. So we have our FlowFuse Expert, our industrial AI assistant built into the platform. It comes with 4 capabilities that matter in practice. So it's an industrial AI assistant. It can help you build your applications from the ground up with a context about your environment, your flows, and your existing data. It's integrated with Node-RED. It can generate the flows on your behalf based on what you're trying to achieve. And it's not generic code. Again, it's flows that are specific to your use case, follow existing standards of what you've already built, and can help debug what's there. And it's contextually driven debugging. Diagnose issues based on what your flows are actually doing, not generic error messages, but try and do targeted root cause analysis. And then we have MCP integration, connecting Node-RED with MCP servers to unlock both your industrial data as well as your IT data to create AI-powered workflows. And I'll come back to MCP in a bit. So here we've got a scenario where we've asked the assistant, can you recommend a node to get values from a S7 PLC? So rather than having to search through manually the catalogue of 5,000 integrations, it's recommended some nodes, and we're integrated with Node-RED, so with one click, takes you into Node-RED and get that node installed. So it can surface the right nodes, the right configurations, and the right patterns for you. In diagnostic mode, I've attached the nodes I've got selected, saying it doesn't seem to be sending the errors back, help me. It's examined the nodes that have been selected. It's identified an issue, there was a missing wire, and it's given you the instructions for what to do to address it. So again, it's this contextual AI that can actually look at what you're doing and provide assistance along the way. Interpreting debug. So in Node-RED, this is the debug sidebar where you can stream live data from your systems to help debug. But sometimes the messages can be a little unclear or out of context. In this instance, you can attach the debug logs to your chat with the expert and get it to help you diagnose what's going on. In this instance, I think it spots a typo in this URL. It sees a 404, which kind of suggests the URL is incorrect, and it's diagnosed the problem and directed you on how to address it. And here we have the beginning of flow generation. So the node in the middle is our function node that lets you drop JavaScript code into a flow to do whatever you want. Here we're having a chat with the expert to help figure out what code we're needed to do this piece of work, and it can actually provide some code. So in conversations with our customers, we're seeing a pattern around typically 4 areas that matter most to the sorts of problems they're trying to solve. Predictive maintenance, OE monitoring, intelligent alarming, and MES SCADA integration. Now, each of these is a place where operational data already exists, and AI can be the key that helps unlock it. So if we think about what does good look like in practice. So we have in situ data conversion. So we want to transform the data where it lives, not after a long pipeline to get it into a central repository. We talked earlier about, the volume of data just makes the problem worse. So we're seeing it's increasingly important that at the edge, in situ, you want to be turning as much of that data into information as you can before flooding it back within your architecture. You have context as a first-class resource. That enables AI to understand the operational context and not just the raw data. So that's understanding what type of machine generated that data, where in the world is that? All the other sorts of contextual information that can provide clues as to what's going on with a particular machine, factory line, facility, whatever it might be. And crucially, we want solutions that work for both sides of the IT-OT divide. For OT teams, you want a universal, easy to learn and flexible enough to adapt to any environment. For IT teams, you want secure by design, You want a low friction for their governance and deployment requirements. And that's the bar. Anything that doesn't meet both sides of that criteria are going to fail in practice. Because whilst there is digital transformation, there is trying to converge this IT-OT divide, the reality is there is always going to be a level of divide. So you want solutions that can bridge that and work in both sides' interests. So I talked about those 4 core use cases. What does this mean in general? So predictive maintenance, you can have the AI detecting anomalies in the sensor streams before failures occur. Cut your unplanned downtime. Not a separate system, but running as a flow right at the edge in situ, right alongside your existing data collection. Your real-time OE monitoring. Live dashboards aggregating performance data across site. No SQL, no data specialists needed. Built by the OT team in hours using FlowFuse's dashboarding tools. And again, a super common pattern we see is the OT engineers suddenly realize there's something new that they want to start monitoring. And with a Node-RED dashboard, it takes 2 minutes just to throw up a new dashboard monitoring something new. And it's that tactical behavior where they don't have to do a long planning cycle, they can just throw up a new dashboard because they think something might be interesting. If it's not interesting, it's not interesting, but it's quick, cheap and easy to do that. And if there's value, that can be super powerful. MES SCADA integration, creating a middleware that can bridge legacy SCADA systems with modern MES without costly re-implementation on either side. Intelligent alarming, I thought I'd missed one. Context aware alarm management, filters noise and surfaces only actionable events, reducing alert fatigue, ensuring alarms that matter actually get acted on. So the pipeline's simple. You've got the PLC and sensor data going through a FlowFuse integration, through an AI-powered transformation into a dashboard and into your decision layer. No requirement for a data lake, no long lead time, just a value from data to action. So one of the things we've built, and again it's an abstract flowchart, is MCP. So this, if you have heard of this, or rather if you've not heard of this, Model Context Protocol. It's an emerging standard for how AI agents can integrate and share data. Share data with themselves, with external tools, systems and other data sources. And we have 3 concepts in MCP. You've got tools, and these are things that an AI can do. Maybe it's query a database, trigger a workflow or read a sensor. You have resources. These are something that an AI can know, knowledge, a maintenance manual, a production schedule, a machine's operating history, the calendar of staffing for a particular facility. And then prompts, and these are things that an AI can ask of the system, pre-built queries that can surface the right information at the right time. What this means for our industrial environments is your operational data, which might be locked in SCADA systems, historians and PLCs, can be made available to your AI agents in a structured, secure and controllable way. Node-RED running within the FlowFuse becomes your MCP server that can bridge your OT world into your AI layer. So putting our FlowFuse Expert into insights mode, it allows us to connect to the MCP servers we've created within our organization, and we ask the question, what's my best performing machine? From that, it's used our data service to query the historian, and it's come up with an answer based on the latest data, machine 3 at so-and-so, and so it's giving us information based on that natural language question, all powered by the fact that MCP gives the AI a way to query intelligently your data sources. What's the weather in Hannover, Germany? So again, a very simple MCP integration. It's all about bringing additional context. Maybe you've got a badly performing machine. Maybe it happens to be a very wet day. Maybe there's just something else going on. Being able to pull these other data sources, you can start inferring other things. So in Node-RED, building out simple MCP tools, we've got a tool to retrieve the current data from the historian, a tool to retrieve the current weather, resources around site managers so you can find out who's on site. Do I have any staff in Hannover? It can query the current work schedule, find out who's on site based on what's going on, and it gives you that way to then ask more involved questions. So perhaps it wasn't the best performing machine. What's my worst performing machine? But more importantly, who do I need to talk to about it? And through MCP integration with your IT data and your OT data, it enables the assistant to answer that sort of question without you having to join all the dots yourselves. It can draw on your operational data, your organizational data, and real-time context simultaneously. Really, if you're sitting here thinking, this sounds relevant, what should you do next, other than come to our stand and come and have a chat with us? We think there are 4 steps here. Assessing your integration debt. Map out your point-to-point connections. Start at the edge. Pick one flow, one data source. The goal is to prove that value in days, if not weeks, not in quarters. Don't try and boil the ocean. Power your OT team. Give your engineers this AI tooling. Reduce the dependency on scarce developers. Build an internal capability that lives in your organization, not in a contractor's laptop. Apologies to any industrial contractors in the room. And then standardize and scale. Turn what works into a template. Use the FlowFuse tooling to help scale that what works right across your organization. What one team can prove, every team can inherit from. So the main takeaways: the IT-OT divide is a solvable problem without ripping out your existing infrastructure. You don't need greenfield projects to make progress. Industrial-tuned AI can accelerate development from months to weeks. For OT teams, not just developers, the people closest to the problem become the people building the solution. Your operational data already holds the answers. AI and Node-RED help you unlock it without a large investment in a data science effort. And an open source foundation helps eliminate a vendor lock-in and gives you the agility your business demands. And finally, we would say the competitive advantage window is now. Manufacturers moving on AI platforms today are setting a benchmark that others will spend years trying to catch up to.
We're really excited about all the innovation that AI with FlowFuse has to offer. The FlowFuse Expert gives you an incredibly powerful way to quickly build your flows, test them, deploy them at scale, and then maintain them over time. If you'd like to get started with FlowFuse Expert and see everything that FlowFuse has to offer, then head on over to flowfuse.com to start your free 14-day trial. This has been Christopher Sandoval. Thanks for watching, and I'll see you next time.